Last lecture I have taken 4 examples. Fifth example I have given you. बरोबर है ना? ओंकार. So fifth example I have given you. So I will solve 6 example of first unit and then I will move to the second unit. Second unit already I have started. In second unit we have discussed introduction and importance. Again I will take a review. This mixing of fluid is very important when we are coming across fast reaction, when we are coming across viscous liquid, when we are coming across heterogeneous system. Heterogeneous system means what? System which contain 2 or more than 2 phases. For that, mixing of fluid becomes very important. Okay, so extremely fast reaction in homogeneous system, heterogeneous systems, for viscous fluid, especially in polymer industry, especially in oil industry, or where fluid is very viscous. Okay, mixing of fluid becomes very important. 2 important parameter in fluid mixing आपण शिकलो हे सगळं झालंय मी कव्हर केलंय गजानन तू गजानन ना तू गणेश ना okay so 2 important parameters we have already covered in fluid mixing. Number 1, degree of segregation and early or late mixing. This I have explained in detail with the help of diagram in last lecture. Then we have discussed very important microfluid and macrofluid concepts. When fluid is as a single molecule, it is known as microfluid. But when fluid contains bunch of molecules, in that bunch of molecules, 10 raised to 12 to 10 raised to 18 molecules are there. 10चा 12वा घात 10चा 18वा घात एवढे molecule असतात एका bunch मध्ये. That bunch is known as aggregates. That bunch are known as cylinder packets. Then that fluid is known as macrofluid. Macrofluids are very common in the heterogeneous system. Macrofluids are very common in polymer industry and oil industry. So this we have discussed already. Self mixing of single fluid, second important topic we have discussed. All the fluids we assume so far are macrofluid. आतापर्यंत आपण तुम्ही पहिलीपासून third year पर्यंत whatever education you have taken, okay, during that you have assumed that fluid is microfluid. Micro means what? Single molecules are wandering here and there and they are colliding with the other molecules. So fluid is microfluid. But in some industries like polymer industries, fluid may be macrofluid. So we will discuss that concept in this unit, short and simple unit. So let us consider PFR, MFR and batch reactor for macro and microfluid. So first we will discuss batch reactor. So what I told in last lecture, in batch reactor, each packet acts at its own batch reactor. Hence conversion in each packet, in each batch reactor is same. Whether fluid is micro or macro, it doesn't affect conversion or product distribution. So whatever equation we have derived for batch reactor in CRE1, same equation we can use for macro fluid. So equation for micro fluid and macro fluid both are same. For batch reactor, only for batch reactor. Then plug flow reactor we have discussed. Plug flow reactor means what? No mixing. Since packet in plug flow reactor packets bunch aggregates of molecules, that is the small batch reactors, are in series without intermixing. एकमेकांमध्ये mix होत नाही. Hence degree of segregation does not affect conversion and product distribution, whether fluid is macro or micro. Now fluid macro असू दे क्या micro असू दे, it does not affect conversion and product distribution in PFR, plug flow reactor. Okay, but case is not like that for MFR. So for MFR, for microfluid, concentration A drops suddenly. का mixing असते ना, and we are having single molecule as identity ना. So concentration of A drops suddenly everywhere. No packets or no aggregate, no packet retain its high concentration. No packets retain its high concentration. Means in microfluid, vigorous mixing is there na, and single molecules are there na. Hence, due to that, each molecule lose its identity. त्याचा पत्ता, त्याची हिस्ट्री, त्याची आयडेंटिटी, त्याची ओळख प्रत्येक molecule lose करतो. You're getting or not? Okay, no molecule retain its high concentration. Its high concentration decreases due to vigorous mixing. You're getting or no? Okay, molecule is not having any history. त्याचा हिस्ट्री काय नसते. आता आपल्याला हिस्ट्री असते ना, आई वडील आजोबा वगैरे आपलं घरचा पत्ता. So similarly, but that molecule in microfluid is not having any history. But it is not the case. बरोबर त्याच्या उलट असतंय when fluid is macrofluid. When fluid is macrofluid in MFR. Similarly, we can't tell molecule is newcomer or oldcomer. Hence, for microfluid in MFR, okay, equation is there. Tau by C naught is equal to B by F naught is equal to XA minus RA. That we have discussed in CRE1. आपण CRE1 ला discuss केलं होतं ना. Okay. But case is not like this. For what? Macrofluid. Hence, we will go for very important derivation on which examples are there. So, hence we will determine performance equation of microfluid or macrofluid in MFR. For that, we have to go for two assumptions. Number one, millions of equal size. I say in macrofluids, bunches are there, na? So first we will assume that bunch are of equal size. असं नसते actually, bunches are of different size, but we will assume that bunches are of equal size. They are churning. Churning म्हणजे काय? roaming. Roaming म्हणजे काय? कसे फिरतात randomly. Churning म्हणजे randomly फिरणं. Okay, they are churning about the vessel. They are moving randomly here and there in the vessel. And second assumption, the extent of reaction in aggregates. The extent of reaction in aggregates depends upon length of stay in the reactor. So if bunch remain in the reactor for more time, conversion is more. Vice versa. Okay, so extent of reaction depends upon length of stay in the reactor and kinetics of the reaction. Kinetics means KNN, rate constant and order of the reaction. So these are very important for this derivation. Okay, then we can write bracket. So here we get okay, first bracket is fraction of reactant unconverted for macrofluid in MFR. In first bracket is equal to summation of all aggregates. But below summation we have to write all aggregates. First bracket, fraction of reactant remaining in aggregate of age between T and T plus dt into second bracket, fraction of exit stream consisting of aggregates of age between T and T plus dt. Same equation I will write mathematically, Gajanan. The same equation mathematically, fraction of reactant unconverted. What is the reactant? A. So fraction of reactant unconverted is Onkar 1 minus x na? बरोबर है? Is equal to C upon C naught. Is equal to C upon C naught. Is equal to summation. I तसं घेतलं summation of all aggregates. आणि पहिल्या fractions पहिलं first bracket on RHS is there. Fraction of reactant remaining in aggregates. त्याचा अर्थ काय mathematically? C upon C naught batch. C upon C naught batch. त्याचा अर्थ. And very important things, meaning of second bracket, fraction of exit stream. हे पाठ पाहिजे लक्षात ठेवा. This is very important. Vishal, fraction of exit stream consisting of aggregates of age between T and T plus dt, that is nothing but EDT. So that I will put. So what is the general equation? So 1 minus x is equal to summation of all aggregates, C upon C naught batch, EDT. That is the general equation for macrofluid in MFR. Macrofluid in MFR. You are getting or not? Okay. Where for MFR, बघा काय दिले मी ते पुढे बघा. Where हे प्रश्न गेटला विचारला होता. This question they asked many times in gate examination. Where for MFR E ची व्हॅल्यू काय असते? E raised to minus t by t bar. E raised to minus t by t bar divided by t bar. Okay. And for first order reaction, this C by C naught batch काय होतंय? From CRE1 तुम्ही करून बघा. Finish. In CRE1 C by C naught batch काढून दाखवतो फायमध्ये दाखवलं असतं. कसं असतंय? What is the equation? Gajanan minus dCA by dt is equal to K into CA na. So that if you integrate in proper limit, we will get C by C naught batch for first order reaction e raised to minus KT bar. So this e raised to minus KT bar we can put here na in general equation. Gajanan, e raised to minus KT bar we can put in general equation. In general equation bracket is this bracket is there na. हे तुम्हाला माझा arrow दिसतो का रे? माझा arrow दिसतोय? मी arrow दिसत नाही माझा. Cursor दिसत नाही माझा. Okay, so for first order reactor, C by C naught batch is equal to e raised to minus KT bar. E raised to minus KT bar. So this e raised to minus KT bar I will put in general equation na. So if I put in general equation, it becomes, if I integrate between 0 to infinity, it becomes for first order reaction for macrofluid in MFR. This equation becomes that complete our main derivation of this chapter. 1 minus XA is equal to 1 upon 1 plus KT bar. Vishal. So this derivation must be by heart to you. This derivation they are asking very frequently. On this derivation they are asking example very frequently. So this derivation by heart must be by heart to you. Okay. So up to this state. So 1 minus x is equal to 1 upon 1 plus KT bar. This is for order. N म्हणजे काय? Order is equal to 1 or macrofluid in MFR. Okay. This equation मला पाठ पाहिजे लागणार आपल्याला example ला. only on this equation examples are there, only 5 examples are there, and that all 5 examples require only this equation. बस बाकी काही लागत नाही आपल्याला. Next, degree of segregation has no effect on conversion for first order reaction, whether fluid is macro or microfluid. As from CRE 1, फार महत्त्वाचं वाक्य लक्षात ठेवा. In CRE 1, you have discussed one equation for order 1, and that equation is same. विशाल, तुम्ही CRE 1 ला जे इक्वेशन शिकले ते इक्वेशन असंच येते. काय येते? 1 minus x is equal to 1 upon 1 plus kt bar. So for macrofluid, it is same, just like microfluid. So what it means? If equations are same, it means degree of segregation. Segregation म्हणजे काय? एकमेकाला चिकटण्याची ताकद. Molecules or aggregates stick to each other. That is only degree of segregation. So you are getting or not? So degree of segregation has no effect on conversion. Degree of segregation does not affect conversion, especially for only first order reaction, because for microfluid equation is same just like for macrofluid. You are getting or not? So that is very important. हा प्रश्न घेतला बऱ्याच वेळा विचारला आहे. For first order reaction, whether fluid is micro or macro, whether fluid is micro or macro, okay, performance equation remains same. Hence, okay, whether fluid is macro or micro, it does not affect conversion. Conversion remains same for first order reaction only, but this is not the case for other reaction. As order changes to second order, third order, conversion changes for macro and microfluid. Okay, for second order reaction, say by say not batch. हा प्रश्न पण गेटला विचारला होता. For second order reaction, say by say not batch is equal to 1 upon 1 plus say not kt. Say not म्हणजे काय? Initial concentration of A. K means what? Rate constant. T means what? Mean decision time. Okay, and for nth order reaction, general equation म्हणून तुम्हाला पाठ पाहिजे. Because if this equation, if you know by heart, तुम्हाला equation जर पाठ असेल, then you can find out say by say not batch for any order reaction. बरोबर आहे ना? So what is the equation for nth order reaction? For nth order reaction, equation is say by say not batch is equal to 1 upon 1 plus n minus 1 say not n minus 1 kt. Okay, bracket complete. कळते कसं आहे ते आशिष? पूर्ण ब्रॅकेट कंप्लीट आहे ओंकार. होल ब्रॅकेट कंप्लीट, ब्रॅकेट रेस टू 1 upon 1 minus n. विशाल कळलं ना? Okay, this bracket, whole bracket raised to 1 upon 1 minus 1. Above equation shows that rise in segregation's important reactor performance or order greater than 1. Equation, मला हे sentence part पाहिजे, by heart पाहिजे. If order of any reaction is 1 or more than 1, 2, 3, then segregation always favored conversion. बघा, as engineers, we have to take decision when segregation should be more. Segregation should be more when order of reaction is 1 more than 1. If order of reaction is less than 1, then destroy segregation. The bunching काढून टाका. But order of reaction is 2, 3 like that, then we have to increase segregation. You have to increase bunching. You're getting or not? So above equation shows that rise in segregation improves reactant performance for n, which order greater than 1 and vice versa. Okay, and early and late mixing, depending upon early and late mixing, हे पण झालेलं सगळं परत डबल घ्यायला झालेलं माहिती होतं. So in vessel or in reactor, each flow pattern through the vessel has definite RTD and E. प्रत्येक फ्लो पॅटर्नचा तुमची कशी एखाद्याची उंची असते, वजन असते, ईच एव्हरीथिंग. तुमचं कसं थंब प्रत्येकाचा वेगळा असतोय ना. ओके, स्पेसिफिक. So each flow pattern in the vessel has specific RTD, specific E, but converse is not true. म्हणजे काय? RTD सेम असला म्हणजे माणूस सेम नसतो, RTD सेम असला म्हणजे फ्लो सेम नसतो. म्हणजे काय? थंब वेगवेगळे असतात. कधी कधी थंब असे एकत्र येऊ शकत नाही, लक्षात ठेवा. पण थंब सारखा असला म्हणजे ती व्यक्ती एक आहे असं होऊ शकत नाही. गेटिंग और नॉट? ओके, सो सेम थिंग इज देयर. ईच फ्लो पॅटर्न हॅज इट्स स्पेसिफिक RTD or E curve. पण ई कर्व सारखा आहे, बट ई कर्व और आरटीडी सेम, इट डजंट मीन दॅट फ्लो पॅटर्न इज सेम. कळते की नाही काय? Depending upon that, for early and late mixings, we are having three types of RTD. RTD means what? Resident time distribution in the reactor. Number one, idealized pulse RTD. So this is applicable for only plug fluid. Hence, no questions of macro fluid or micro fluid or early or late mixing. Plug fluid का फरक पड़ता नहीं. Next, exponential decay RTD. It is only for mixed fluid. I will draw diagram. Diagram करतो मी नंतर. So this also holds for some other systems. Number one, set of parallel plug flow reactor. Set of parallel plug flow reactor means what? Plug flow reactors we are keeping above one another. Half plug flow reactor, parallel is second plug flow reactor, third plug flow reactor, fourth plug flow reactor. So set of parallel plug flow reactor. Plug flow reactor with side stream. Plug flow reactor with side stream. बाजूला आपण एक stream बाहेर काढतो. With side streams. Are you getting or not? Okay. So these are some systems for which we are using exponential decay RTD. तर माझ्याकडे चूक झाली. तिथं काय पाहिजे होतं? Actually exponential decay RTD पाहिजे होतं. Exponential RTD मध्ये एक शब्द पाहिजे होता decay. Exponential decay RTD. Okay. And earliest mixing conversion given by CRE1 performance equation. Okay. तिथं काय महत्त्वाचं नाही. Arbitrary RTD. Okay. So one RTD we have for idealized pulse RTD PFR. Other RTD we have for exponential decay RTD. Mixed flow. So plug flow and mixed flow both are ideal extremes na, Ganesh. But actual reactor is in between plug and mixed flow na. Actual reactor is having some plug flow, some mixed flow. So for actual reactor we must have some RTD na, and that is the third RTD. So for actual reactor which lies between plug and mixed flow, this is a plug flow, this is a mixed flow, which lies between plug and mixed flow, we are having third RTD, and that RTD is known as arbitrary RTD. It holds for actual reactor. It holds for condition, flow condition, actually between PFR, ideal PFR and MFR. You're getting or not? So like that, we're having this, the RTDs, three types of RTDs. Three types of RTD discuss. Okay, next. Factors affecting performance of the reactors. हे सगळं घेतलं मी परत घ्यायला लागलो काय? Factors affecting हे सगळं झालं होतं माझं ऍक्च्युअली. Factors affecting performance of the reactors are. हा प्रश्न परीक्षेला वारंवार विचारतात. This topic is there in your last chapter of your syllabus. Last chapter मध्ये आहे बघा. But this chapter I am covering here. If you check last 2-3 year paper, you will get that normal paper, not corona paper. कोरोनाच्या आधी पेपर बघू नका. ठीक आहे, objective. Okay, so subjective paper if you check, and you will get that this question they are asked many times for short notes for 6 marks. Factors affecting performance of reactor. Write the short notes. R number 1 kinetics. म्हणजे काय? K rate constant, N order of reaction, RTD residence time distribution, how much molecule remain there for how much time. That is important na. RTD म्हणजे E म्हणजे C म्हणजे J dash theta. We have discussed that in chapter number 1. So RTD or E. Next, degree of segregation, whether there is bunching or not. If bunching is more, एकमेकाला चिकटण्याची प्रक्रिया जास्त असेल. Okay, if bunching is more, degree of segregation is more. Bunching is less, degree of segregation is less. Segregation म्हणजे काय? एकमेकाला चिकटण्याची क्रिया. Okay, so bunching, so degree of segregation. And last factor is early or late mixing. Whether fluid mix, मी सांगितलं डायग्राम पण मी दाखवलं होतं. Whether fluid mix is early in the reactor or later in the reactor. पहिल्यांदा टाकल्या लगेच मिक्स होतंय का नंतर मिक्स होतंय. Okay, these are the main factors on which performance of any reactor depends. Next sentence in same topic. At low conversion, RTD, early or late mixing or segregation does not affect more. फार महत्त्वाचं लक्षात ठेवा, वाक्य लक्षात ठेवा. But as conversion increases, RTD, early or late mixing or segregation affect more. Ganesh, you are getting or not? So if conversion is less, RTD, early or late mixing, segregation महत्त्वाचं नसते लक्षात ठेवा. But as conversion increases, early or late mixing, segregation becomes important. RTD becomes important. Okay, next. For multiple reaction, RTD, early mixing or late mixing, segregation affect conversion. We know single reaction is there, A gives R. But multiple reaction asते, A gives R, but A gives B. Multiple reaction. Multiple reaction means what? More than one reaction. Okay. So for single reaction, RTD, early or late mixing or segregation does not affect. But if reaction is multiple, series reaction, parallel reaction, side by side reaction, okay, then RTD, early or late mixing and segregation affect conversion more. Become important as compared to single reaction. For example, free radical polymerization, very fast. Free radical means randomly move. Free radical polymerization in polymerization reactions. It is very fast reactions. Its degree of segregations affect conversion in reaction. Bad. You're getting or not? त्यामुळे पॉलिमर इंडस्ट्रीमध्ये सो आता तुमच्या वर्गातली एक आर्या म्हणून मुलगी आर्या बिसे शी इज व्हेरी मच इंटरेस्टेड टू गो फॉर हायर एज्युकेशन इन पॉलिमर. Okay, so there you will come across this word macro food. Okay, so in polymer industries segregation affect lots. Plastic polymer है ना, plastics और polymers है. Okay, next this topic I will discuss and I will stop. अतिशय महत्वाचा topic है models for partial segregations. From this chapter only do two topics. Number one derivation, number two this topic. Now I am going to discuss in this lecture an example. दोन example आहे तेवढं करा त्याच्या बाहेर काय पडत असतं. Second unit is our own. आपलं दुसरं युनिट संपून जाते लक्षात ठेवा. Okay, so numerous methods are there to treat segregation. Segregation define केलं पाहिजे ना. तुम्हाला डिफाइन करण्याकरता कॅम्पस इंटरव्ह्यू मध्ये तुमचे मार्क आपण बघतोय ना. Similarly, to define segregation, okay, we are having some models to treat segregation, to measure segregation. Segregation measure करण्याकरता आपण काही tools आहेत. We are having some tools to measure segregation. Okay, so numerous methods are there. In that numerous method, one method is very common, and that method is known as models for partial segregations. So partial segregation, partial म्हणजे काय? झिरो पण नाही आणि जास्त पण नाही, दोन्हीच्या मध्ये. ओंकार, partial म्हणजे झिरो segregation म्हणजे PFR. MFR म्हणजे काय? सॉरी, झिरो segregation म्हणजे MFR. PFR means maximum segregation. But in between that, we are having actual fluids na, which are having some segregation. So that is known as partially segregated fluid. So to define that segregation, to treat that segregation, to study that segregations, numerous methods are there. Out of that, one method is very common and important for our syllabus, and that method name is models. Three models are there. Number one, intensity of segregation model. पहिल्या मॉडेलचं नाव काय? गणेश, intensity of segregation model. This model is given by scientist Danckwerts in 1958. Hence, it is also known as Danckwerts model. Spelling बघा, D capital पाहिजे. आपल्या पोरांना अशीच कळत नाही. सायंटिस्टची नावं, पहिला अध्याक्षर, पहिलं फर्स्ट letter should be capital. So Danckwerts D should be capital. Okay, in 1958 he has given this model. त्यांना काय इमॅजिन केलं? Danckwerts imagine who picture म्हणजे इमॅजिन केली, कल्पना केली. Actually नव्हतं ते, त्यांना इमॅजिन कल्पना केली. Who picture that partially segregated molecules of different age and concentration intermix randomly. Okay, intermix randomly, diffuse into each others to give mean age or composition of aggregate. एकमेकांमध्ये विरघळतात, एकमेकांमध्ये मिक्स होतात. मग काय होणार मिक्स झाल्यानंतर? they gives mean age or average composition of aggregate. एकमेकांमध्ये मिक्स झालं ना, पण त्याचं काय होणार? ते अवरेज होणार ना. आता एकाचं वय 21 आहे, एकाचं वय 20 आहे. मी अवरेज काढलं, 21 होणार ना. गेटिंग ऑर नॉट? सिमिलरली these all molecules get merged, diffuse to each others, okay, to give mean age or mean composition of aggregates. And he defined very important parameter for his model, and that parameter is known as intensity of segregation of fluid. त्या पॅरामीटरला काय म्हणायचं? intensity of segregation of fluid. And that model is shown by letter J. तुमच्या कॅम्पसला, तुमच्या ओरलला, तुमच्या गेट एक्झामला हे विचारतात. Define that J parameter म्हणजे काय? So J parameter is given by Danckwerts in his model to treat degree of segregation. By that parameter we can treat, we can measure, we can study degree of segregation. And that parameter is shown by letter J that parameter is known as intensity of segregation parameter. How we can define it? J is equal to sigma square. मला ते वर्ड डोक्यावर लिहिता आले नाही, मला सांगायला सिग्मा स्क्वेअर आहे ते व्हॅरियन्स. सिग्मा स्क्वेअर म्हणजे काय? व्हॅरियन्स वी हॅव स्टडीड इन लास्ट चॅप्टर ना. सिग्मा स्क्वेअर अमंग ऍग्रीगेट्स डिवाइड बाय सिग्मा स्क्वेअर अमंग मॉलिक्युल्स. सिग्मा स्क्वेअर अमंग अमंग म्हणजे काय? मधी भरपूर आहेत ना ऍग्रीगेट्स, बिटवीन म्हणू शकत नाही, अमंग म्हणलं पाहिजे भरपूर असतील त्यावेळी. सो सिग्मा स्क्वेअर व्हॅरियन्स अमंग ऍग्रीगेट्स divided by variance among molecules, that is known as J parameter, intensity of segregation parameter. अतिशय महत्त्वाचं समजून घ्या. गेटला विचारले बऱ्याच वेळा, पुढचं हा प्रश्न तर गेटला वारंवार विचारतात. J is equal to 1 for macrofluid. सेग्रिगेशन सगळ्यात जास्त असते ना मॅक्रोफ्लुइडला, म्हणून J 1 असते. For macrofluid value of J is dot dot dot. For macrofluid value of J is maximum 1. And for microfluid in MFR. In microfluid म्हणजे काय? Single molecules are there ना, so no aggregation is there ना, intensity of aggregation is less ना, minimum ना, hence J is equal to 0. You are getting? हे व्हॅल्यू लक्षात ठेवा, लक्षात ठेवा. Hence J is equal to 0 for microfluid in MFR. J measures degree of segregation as well as RTD also. हा प्रश्न पण विचारला आहे गेटला, म्हणून मी वाक्य टाकले हे मुद्दाम. J measures degree of segregation. J is equal to 1, segregation is more. J is nearby 0, segregation is less. But as well as J gives RTD. It does not give only degree of segregation, but as well as it gives RTD, residence time distribution also. Earliness of mixing must be known to use J. हा प्रश्न पण गेटला विचारलाय, म्हणून मी वाक्य टाकली सगळी. J काढण्याकरता आपल्याला ही माहिती पाहिजे, लक्षात ठेवा. काय माहिती पाहिजे? अर्ली मिक्सिंग इज लेट और अर्ली, ही सुद्धा माहिती पाहिजे. Okay, this complete our first model, Dankworth model. Okay, I will go for second model, which is known as Colenses model. काय? Colenses model. It is given by scientist Curl. C should be capital in 1963. पहिलं मॉडेल 1958 ना, आता हे 1963 5 वर्षानंतर. He assumed, hence this model is also known by his name, Curl model. Okay, त्यामुळे तुम्हाला ओरलला विचारलं डिस्कस कर्ल मॉडेल म्हणजे हे मॉडेल लक्षात ठेवा. त्याला दुसरं नाव काय आहे? कोलेन्सिस. कोलेन्सिस म्हणजे काय? कोलिजन, कोलिजन बिटवीन द मॉलिक्युल्स, कोलेन्सिस मॉडेल. ओके, ही अश्यूम, ही इमॅजिन मॉडेल ऑफ डिस्पर्स्ड फेज ड्रॉपलेट्स. त्यानं अश्यूम काय केलं? एक स्टर टँक आहे, स्टर टँक रिएक्टर आहे. इन द स्टर टँक रिएक्टर्स ड्रॉपलेट्स आर देयर. आपण रॉकेट टाकलं पाण्यामध्ये, ड्रॉप्स तयार होतात ना. ओके, देन इफ यू मिक्स दॅट अँड दॅट गेट अटॅच ना, ते त्याने इमॅजिन केलं, कुणी करलं. सो ही अश्यूम दॅट okay, one ideal stir tank reactor is there, and inside that dispersed phase droplets are there, different phase droplets are there, heterogeneous phase I is there. Okay, collision between droplets matter a lot. These droplets get collide with each other, that's why it is having name colenses. Droplet get collides, droplet get colenses. Okay, lot to give macrofluid or microfluid. आता मला सांगा, हे जर ड्रॉपलेट सारखे एकमेकाला कोलाइड झाले, काय होणार? ते मोडणार ना, एकमेकाला कोलाइड झाले की ते मोडणार ना. सो फ्लुइड मोडणार म्हणजे काय? फ्लुइड विल बिकम मोर मोर मायक्रोफ्लुइड ना. एकमेकाला कोलाइड कमी झाले, ते मोडणार नाहीत. दे विल रिमेन ॲज इट इज मॅक्रोफ्लुइड. यू आर गेटिंग और नॉट? सो बिटवीन collision between droplet matters a lot to give whether fluid is macrofluid or microfluid. And Curl defined one parameter. त्या पॅरामीटरचं नाव आहे I. I म्हणजे इंटेन्सिटी ऑफ सेग्रिगेशन. काय? फार महत्वाचं, मुलांना कळत नाही. I म्हणतात आणि म्हणतात I, नाव मला माहित नाही म्हणतात. I म्हणजे इंटेन्सिटी ऑफ सेग्रिगेशन. सॉरी इंटेन्सिटी ऑफ कोलिजन. सॉरी, I is intensity of collision. Okay, so there I have written I is equal to average number of collision experienced. The experienced, right? I is average number of collision experienced by drop passing through the vessel. आता मला सांगा, I is 0 म्हणजे collision काहीच नाही ना गजानन. I 0 म्हणजे काही नाही. इंटेन्सिटी ऑफ कोलिजन 0 आहे म्हणजे काहीच नाही, कोलाइड होतच नाही. म्हणजे फ्लुइड इज मॅक्रोफ्लुइड ना, कारण कोलिजन झालं तरच ते ब्रेक होणार ना. बट इफ इंटेन्सिटी इज इन्फिनिटी, सारखं एकमेकाला, इफ दे कोलाइड देन that aggregate will break down ना, and fluid will becomes microfluid. हे फार महत्वाचं आहे. I is equal to 0 for macrofluid and I is equal to infinity for microfluid. This model uses Monte Carlo procedure. हे फार महत्वाचे आहे. If you visit IIT or ICT, there simulation for simulation in Aspen Plus. तुम्हाला माहित नाही Aspen Plus का? For that they are using Monte Carlo procedure. Okay, for simulation model तयार करायचं, नंतर model तयार केल्यानंतर काय करायचं आपण? We have to go for simulation ना. So for simulation, we are using this very common method in the industry, in research, and that method is known as Monte Carlo method. So this model uses Monte Carlo method procedure for simulation after modeling. It can be used for any kinetics. मला विचारलं या 3 मॉडेल मध्ये सगळ्यात चांगलं कुठलं? तर कर्ल मॉडेल. का? Because for any kinetics we can use. For multiple reaction we can use. For multiple feed, reactor आहे त्याला भरपूर feed आहे कशा. For multiple feed we can use. For multiple product we can use. Number of products आहेत. For multiple product we can use, and for any RTD we can use curl model, which is also known as Coalescence model. Coalescence means क्या? Collision. Negative or not? If any question you can ask. Last model, and after this I will stop. 2 environmental model. Third model, which describe, which treat. हे model कशा करा शिकतोय तुम्हाला कळलं पाहिजे. By this model we are measuring, we are studying segregation. How much segregation is there? Segregation जास्त आहे काय कमी आहे? We are getting by this model. So third model is 2 environmental model. This model is given by Nigg and Rippin, N and R should be capital, in 1965. 58, 63 आणि आता 65. सगळ्यात नंतर ओके ही assumed ह्यानं पण assume केलं. He imagined arbitrary RTD consisting of unmixed inlet fluid. त्याला त्यानं नाव दिलं entering environment and already mixed fluid, living environment. And fluid moves between these 2 environments. ते 2 environment मध्ये fluid move करते by mechanism सांगतो तुम्हाला मी. ओके पुढे तुम्हाला सांगे करेल. So Nigg and Rippin imagined arbitrary RTD consisting of 2 environment, entering environment आत येणार आणि लिव्हिंग एन्व्हायरमेंट बाहेर पडणार. बरोबर आहे ना? रिएक्टर मध्ये आत काहीतरी येते बाहेर काहीतरी पडते ना. सो आत येणाऱ्याला त्याला काय म्हटलं? एंट्रिंग एन्व्हायरमेंट. बाहेर पडणाऱ्याला त्याला काय म्हटलं? लिव्हिंग एन्व्हायरमेंट. ओके सो आज जे काय येते ते मिक्स झालेलं असते काय रे विशाल? ते मिक्स झालेलं नसते म्हणून त्याला नाव काय दिलं त्यानं? अनमिक्स्ड इनलेट फ्लूइड. आणि बाहेर जे पडते ओंकार ते मिक्स झालेलं असते ना. सो दॅट इज नोन एज ऑलरेडी मिक्स्ड फ्लूइड. ओके असं नसते ना. अँड फ्लूइड मूव्स बिटवीन दिस 2 एन्व्हायरमेंट. In these 2 environment, inlet and outlet environment, living environment, fluid moves by mechanism, okay, rate which is proportional to amounts of material in inlet environment and concentration difference between 2 environments. बरोबर ना? We have discussed that na. In mass transfer 1 we have discussed that. This rate of diffusion depends upon concentration difference na. If concentration difference is more, diffusion will be more na. Similarly depends upon amount of material in inlet environment. जेवढं raw material जास्त आहे तेवढं बाहेर पडणारं material जास्त ना. Okay, this model does not account for earliness of mixing. This model does not take into consideration early or late mixing. हा प्रश्न गेटला विचारला होता. In these 3 model, which model does not take into account early or late mixing? कुठलं मॉडेल? 2 environmental model. Okay, त्याच मॉडेल मध्ये सुझुकी सायंटिस्टचं नाव आहे, गाडीचं नाव नाही आहे काय विशाल. सुझुकी in 1970 modified this model. त्यानं हे मॉडेल मॉडिफाय केलं. हेच मॉडेल 2 environmental model काय केलं? He gave similar model, similar concept, where clumps of inlet fluid shrinks depending upon its size and energy input to it. त्यानं एवढं एकच वाक्य सांगितलं, बाकी काही नाही. In 1970, Suzuki suggested modify same model, and he modified only by 1 sentence. He used similar model, same model, where clumps of inlet fluid shrinks. Shrinks म्हणजे काय? साईज ने कमी कमी होतात. डिपेंडिंग अपॉन साईज, जेवढं साईज जास्त तेवढं सिंकिंग जास्त. And depending upon energy input to it. If energy given to that fluid is more, sinking is more ना. आणि जास्त हलवलं, if we agitate more, okay, that fluid will get shrink more ना, मोडणार ना लवकर. Okay, so and for that he has taken one example of ice cube in vessel. त्यानं घेतलं ice cube in vessel चं एक्झाम्पल घेतलं. काय एक्झाम्पल घेतलं? सोपं. Okay, take one beaker. From the fridge refrigerator, you can take ice cubes. आता पहिल्यांदा ice cube काय आहेत? आपण ते ice cube घेतले, नंतर हलवले, थोड्या वेळ हलवले आपण. So initially, so whatever ice cube we are taking from the refrigerator now, these are inlet environment. That beaker we will mix, we will agitate for some times. After some times we will check, we will remove whatever there inside the beaker. काय आता मी बघणार काय असणार हलवल्यामुळे थोड्या वेळानंतर सगळे क्यूब whatever cube are there can we get as it is. अरे बर्फाची क्यूब वितर मेल्ट होणार ना, सारी गोष्ट असं हलवलं की थोड्या वेळानं मेल्ट होणार नाही. So in outlet we will get melted cubes plus water. अरे बरोबर आहे की विशाल, पहिल्यांदा आईस क्यूब होते फक्त पाणी नव्हतं, पण आफ्टर सम टाइम्स ओके ड्यू टू मिक्सिंग or due to some time okay we will get melted cubes and some water we will get. That is known as outlet environment. Reading or not? So this complete our very important topic, modules for partial segregations. Now next topic is there, but I don't know whether my teacher is coming or not. टाकलाय ठीक आहे. I will continue this in the lecture at 11:50. 1 minute I will take attendance only. EPGS 4 बोर कमी आहेत जुटून शिकवतो, डेटापासून शिकवतो, विषय अवघड आहे आणि EPGS 4